Among the many different kinds of research being done on the International Space Station, there are some experiments that are trying to develop new technologies that would benefit future deep space exploration or life on Earth. And then there are some where both of those things are the case. One example in that latter category is an experiment that is known as synthetic muscle, and that's flying on the International Space Station now in order to test how it holds up under the radiation that exists in space. Joining us this morning to tell us more about it is the principal investigator and developer of the product, Dr. Lenore Rasmussen, the founder and chief technology officer at Ras Labs in Quincy, Massachusetts. Good morning, Dr. Rasmussen.
Good morning, Pat.
Your product, synthetic muscle, is intended to do, I guess, just what the name implies. How did you become interested in developing a product like that?
When I was in grad school, I have an agricultural background, and one of my cousins was working on the farm and was injured pretty severely. And as the resident scientist in the family, I was put in charge of looking at prosthetics. And there are some wonderful solutions, but I was kind of disappointed nonetheless in what I found, and felt as a kind of young, naive chemist at the time that if you could develop something that responded to electricity or some other stimulus, you could kind of bridge that gap between form and function. You could make a prosthetic that both looked and moved naturally.
Now, part of what I understand you're trying to develop this for is that it will have an impact in robotics in space. Why would a synthetic muscle improve the performance of a robot?
Several reasons. Part of what I'm trying to do is to produce human-like grasp, which is both gentle and firm. And for robotics, particularly for grippers, that remains a challenge. Also, our materials are self-sensing, which means when there's mechanical pressure, the impedance changes. So not just for prosthetics to move naturally and to be able to sense what's going on, but for robotics, that element that is often missing is touch, that these can be integrated into one solution would revolutionize the way we look at motion.
Now, you got some help from CASIS in order to get this experiment on orbit, right?
Correct. Yeah, CASIS was very useful. Actually, in mentoring, I was one of the Mass Challenge 2013 Global Accelerator, went through that program, and that's where I met CASIS. Cynthia Bohut was one of my mentors. And my materials, though my focus was on the prosthetic community, I have done extreme temperature conditions prior to that when I was, back in the Princeton area. These materials lend themselves to being radiation resistant, the class of polymers that they're in, plus we did some additives and coatings on the ISS experiment. So that just it was a great fit. It's been a wonderful experience.
Explain to me what it is that is happening with your experiment on orbit now.
Okay, I actually have a mock experiment that, just to show people. There are four kind of protective cages, a little more sophisticated than this, but they each have 8 samples. One of them is my synthetic muscle. Then the next 2 slots have different additives to enhance the radiation effect. Then the next few slots have coatings, various coatings, such as the mylar that's currently being used in space suit technology. Also some specialized coating from the U.S. Army Natick Labs. And then the last 2 spots have combinations of inhibitors and coatings. There's 4 of these. 2 of them are my Generation 3 material. 2 of these cages up there are my Generation 4 materials. And then in these microenvironments, they're all encapsulated separately. There's like one Teflon bag around it. So each of the generations has a dry and a moist environment. In order for the synthetic muscle to work, it operates best moist, just like real human tissue. But it can be dried and then rehydrated. So that's one thing to consider for traveling is, could it be, desiccated, dried out, and then wherever it lands, be reactivated with moisture. And then of the 4 experiments up there, I also have 4 on Earth under the same conditions as kind of like the twin. It's the control. It's like the twin study. So there's 32 samples and 4 protective cages on the ISS, and the same here on Earth in our Quincy lab.
It'll be very interesting for you to get those samples back and move on to that next step. Thank you for taking the time to tell us about it this morning. I appreciate that.
Oh, thank you. Yes, I can hardly wait to, most of the analysis will be back here on Earth to see how they
Dr.
held up.
Dr. Lenore Rasmussen is the principal investigator of the synthetic muscle experiment that's underway now on board the International Space Station.